Welcome students. Today we can start our fourth chapter, that is periodic table. Okay, periodic table. Now we are familiar with what different types of elements and their symbols and etc. and their number of electron, atomic number, etc. We are familiar. So today we are going to discuss about the periodic table and how the periodic table is formed. So there is a comprehensive tool for the arrangement of elements that are generally known as what? Periodic table. It is made easier about the study of elements in chemistry. So different scientists are introduced different methods for the formation of a modern periodic table. Different kind of experiments will be takes place, different ideas will be put forward, and some of them accepted and later it will be discarded. Like that, now we are using the modern periodic table, and it is introduced by Moseley. It's a scientist who introduced the modern periodic table. We are saying the modern periodic table 120 elements are arranged in the increasing order of their atomic number. As we are saying in our textbook related with the periodic table. Before that, we are studying about the formation of the periodic table or history of periodic table. What happens for how the periodic table is formed as a new structure, and who are the scientists who are behind the formation of periodic table and periodic law, etc. So first of all, we are studying about Antoine Lavoisier. Antoine Lavoisier is a scientist at the time of 1789. In the case of French Revolution, we study about Lavoisier. So 1789. In 1789, there is only 30 elements are known. Only know about 30 elements. So first classification is done by Antoine Lavoisier. He classified the 30 elements into metals and non-metals. So he classified the elements into metals and non-metals. So who classified the elements into metal and non-metal? It is by Antoine Lavoisier. This is the first classification related with elements. So this is the first classification. Is that Lavoisier? What he do? He classified the non-elements, 30 elements, into metals and non-metals. But the limitation is that it does not give a position for metalloids. There is another variety. Is there metalloids? It is not possible to give a position for what? Metalloids. So that is the limitation. Due to that limitation, this idea will be discarded. Okay, so the first classification is done by Antoine Lavoisier. The 30 elements, non-elements is there. They are classified into metals and non-metals. But the limitation is that it is not possible to give a position for metalloids. Metalloids, the elements that shows both property of metals and non-metals. They are known as metalloids. But he does not give a position for them. So that's why that is the main limitation, and the idea will be discarded. Next one by Anne Dobereiner. Dobereiner. His name is Dobereiner. So Dobereiner do that. He just take 3 elements. The 3 elements are similar in their property. The properties in their 3 elements. Ore swabhavalla 3 elements. The elements with similar property will be taken as a group, and he gave the name for the group as triads. Right? 3 elements with similar property into a group, and the group is known as triads. I give an example is there: lithium, sodium, and potassium. After classifying that, he observed that the atomic mass, it's a very important idea put forward by Dobereiner. It is triads. What is triad? The element with similar property. 3 elements with similar property is classified as a group, and the group is known as triads. And after that, he observed that the atomic mass of the elements. He observed that the average atomic mass of the first and last element is equal to approximately equal, and sometimes it is exactly equal to the second one. Here the atomic mass of lithium is 7 and the atomic mass of potassium is 39. What is the average of that? 39 plus 7 plus 2. Divided by 2. 39 plus 7 divided by 2. So 46 divided by 2 is equal to 23. So that is the atomic mass of what? Sodium is proven. So the average atomic mass of the first and last element is approximately equal to the second one. That is identified by what? Dobereiner. Okay. And the limitation is that he does not be able to classify all the elements into triads. Does not able to classify all the elements into triads. Annariyapettirunna ella elements ne triad aaki maatan pattiyilla. Okay. Does not able to classify all elements into triads. So this is a major idea related with that. Okay, the average atomic mass of the first and last one approximately equal to the second one. So here the idea of atomic mass will be put forward first by Doberman. Then later it will become by what? Newlands. At that time there is 50 elements are known. Known elements are 56 elements. Then he do that, he arranged the elements in the increasing order of their atomic mass. Important. By Newlands, he arranged the 56 elements in the increasing order of their atomic mass. If it is arranged in the increasing order of their atomic mass, he observed that the first element and the eighth element, first one and the eighth one have similar property. Okay, second one and the ninth one have similar property. So the eighth one repeats the property of the first one. Like that he observed and he introduced a law that is known as law of octaves. The eighth one have the property of the first one. In the increasing order of the elements, arranged in the increasing order of their atomic mass, they observed that the first one and the eighth one have similar in their properties. Okay, so that is known as law of octaves. Then later, the most important person is Mendeleev. Dmitry Ivanovich Mendeleev, that is his name. Dmitry Ivanovich Mendeleev. So we simply call it as what? Mendeleev. So he is the father of periodic table. Father of periodic table is Mendeleev. Then they will ask, who is the father of modern periodic table? Father of modern periodic table is Moseley. Father of periodic table, it is Mendeleev. So he also arranged the elements in the increasing order of their atomic mass. That's very important area related with what Moseley and Mendeleev that we can discuss in the next class. Okay, thank you.